This is the Chapter 6 pre-class lecture on energy. Energy is the capacity to do work. There are many different types of energy, and most of those types of energy fall under the category of either potential energy or kinetic energy. Or those types of energy are produced through the transfer of potential and kinetic energy into those other types or forms of energy. Potential energy is stored energy, either due to position of an object, and that's the physics or gravity-based definition of potential energy, or due to chemical composition, which is called stored chemical potential energy, and that's the more chemistry definition of potential energy. And then there's kinetic energy, which is universal, because that is the energy due to movement of an object. And so whenever work is done on an object, work is done on an object due to movement of an object against a force. And so work, therefore, being equal to the force that's applied to an object times the distance that that object travels. And so therefore, work being performed is transferred into the kinetic energy, which results into the movement, of course, of that object. And then also note the differences between heat and energy and the relationship between heat and energy. And also note the difference between heat and temperature. So when we talk about energy, of course, we want to know, well, what are the units? The metric or SI system unit for energy is the joule, symbolized with a capital J. And so joule being the amount of energy needed to raise the temperature of a 100-gram object by 1 meter against the force of gravity, or the amount of energy required to raise that 100-gram object in that distance of 1 meter against the force of gravity, saying that's how much energy it takes to perform work on that object, to cause that object to move a distance of 1 meter. And so another unit that's used for energy is the calorie. Note there are 2 calories. There's a lowercase c calorie, and that's the amount of heat that's required to raise the temperature of 1 gram of water by 1 degree Celsius. Then you have the dietary calorie, capital C calorie. And so to convert in between these units, we have these conversion factors shown here. So if a slice of pizza contains 217 calories, and note that's calories with a capital C, express this value in lowercase c calories. So 217 capital C calories, that's our dietary calorie, it's equivalent to 1 kilocalorie with a lowercase c. So we do that conversion. 1 capital C calorie equivalent to 1 kilocalorie. Capital C calories cancel. Then how is a kilocalorie related to a calorie, both with the lowercase c? Well, 1 kilocalorie is 1,000 calories. So this takes a 2-step conversion. Now kilocalories cancel. We do the math. We get 2.17 times 10 to the 5th, lowercase c, calories. Expressing this value in kilojoules, 217 capital C calories. How many kilojoules is this? And so we see that a capital C calorie, again, is 1 kilocalorie. And 1 kilocalorie is 4.184 kilojoules. We first convert the capital C calories to kilocalories. And then, with the capital C calories canceling, we do the final step, converting the kilocalories to kilojoules. And now doing our math, we get 9.08 times 10 to the second kilojoules. If a bag of potato chips has 70 kilocalories, and if we assume that all of the energy from eating these chips goes towards keeping our heart beating, and if each heartbeat requires 1 joule of energy, how long can these chips sustain a heartbeat of 80 beats per minute? So how long means time, like how many minutes? And we're given the information that each heartbeat requires 1 joule of energy. That is a conversion factor. So for every 1 heartbeat that takes place, there is 1 joule of energy being used. So that is a conversion factor. 1 heartbeat per 1 joule. So now let's convert these 70 kilocalories to minutes. So this is where we're starting. This is the question that we're trying to answer. How many minutes will these chips sustain a heartbeat of 80 beats per minute? So we have the chips with 70 kilocalories of available energy. And we notice that everything else that we're given, as far as our conversion factor for heartbeats, are in joule units. So we would want to convert the 70 kilocalories to joules. And then convert the joules to heartbeats. And then the heartbeats to minutes. Okay. So first, let's convert those kilocalories to joules. We have our conversion factors here. We can convert a kilocalorie to a kilojoule first. And then, of course, there are 1,000 joules per 1 kilojoule. We can add that to the list. So in converting the kilocalories to joules, we convert them actually to kilojoules first and then to joules. So that's going to be 1, 2, 3, 4. So it's a total of 4 conversions that we're going to do to solve this problem. So first, kilocalories converted to kilojoules. For every 1 kilocalorie, there are 4.184 kilojoules. That's the first conversion. The second conversion, converting the kilojoules to joules. For every 1 kilojoule, there are 1,000 joules. Next conversion, convert the joules to heartbeats. And there's our conversion factor. For every 1 joule, there is 1 heartbeat. So now our joules cancel, our kilojoules cancel. Last step, convert the heartbeats to minutes. There's our conversion factor. 80 heartbeats per minute. So for every 1 minute, there are 80 heartbeats. Now the heartbeats cancel, and we're left with the unit that we want, and that is minutes. So we do our math. 70 times 4.184 times 1,000 times 1 times 1. We do that math by multiplying all the numerators together. And then we see our denominators. They're all ones except for one unit of 80. And so take our product of multiplying our numerators together and then simply divide by 80. We will get 3,700 minutes, or 3.7 times 10 to the third minutes. Now, if we have a soda, 12 ounces of it, and the energy in that soda is equivalent to 92 kilocalories, what is the energy released when metabolizing this beverage in units of kilojoules? So we're just converting kilocalories to kilojoules. This is only a 1-step calculation, whereas in number 2, we had to do 4 steps. So 92 kilocalories. We want kilojoules. So kilojoules go in our numerator. Kilocalories go in our denominator. For every 1 kilocalorie, there are 4.184 kilojoules. Kilocalories cancel. We do our multiplication. We get 380 kilojoules. And that brings us to the end of our pre-class lecture on energy units and converting between these various energy units.